history. Who built Taj Mahal? Shah Jahan. You can't question. It's a data information. So can't we question like this? Yes, you can question. So we'll do one thing. I'll take a simplest example. I'll project a small body of mass m with a velocity say v naught as it ascends. Now we all know we all know some. So it will ascend certain height, and when it is ascending here, what are the forces that will be acting? Mg and nothing but the gravitational force, no? And it will have velocity say v1. So what about the as it moves from A to B? What is the work done by gravity? Will be negative. it will come to it will come to instantaneous rest here. Again, it will start descending. So here mg will be there, and the velocity say same v1, and finally to strike back the ground with the same speed. Is it okay? What is the net work done? So work done to move from A to B. You write minus mgh. Any reason for that? Because the weight is acting opposite to displacement. Then work done to move from B to A, mg into h. Net work done by the gravity. So net work done by a conservative force in closed path will be 0. I think there's a basic definition. Then F will be what? Conservative force. So here also the same idea, no? So the net work done by the weight. Weight is nothing but the gravitational force here. So net work done by this, there's a closed path. So what do you mean closed path? Actually, in fact, it will not turn here. It will just ascend and retrace path. So net work done in closed path is 0. So therefore, this mg is what? Conservative. And what is that mg? Mg is a what? Like gravitational force here. So therefore, now, sir, here is okay, but what about particles? See, anything. There's a gravitational force between particle. Here, gravitational force between the object and the earth. Altogether, everything it's like a gravitational force only. The nature is gravitational force. So therefore, conservative force acts. And so therefore, as it is a conservative force, here what is force acting on particle is a conservative force. And moreover, so what happened? Work done in closed path is 0. As it is a conservative, so mechanical energy will be conserved here. So as mechanical energy is conserved, so therefore what I do? Ui plus Ki equal to Uf plus Kf. Initial interaction potential minus G m1 m2 R. Separation. The release from rest x plus m1 v1 square But how many unknowns are there? V1, V2, two unknowns are there. We need one more equation. What is one more equation? I'll go for conservation of linear momentum because center of mass will not shift. What is the net force acting on system? Is 0. So therefore initial momentum equal to final momentum. Initial momentum 0, final momentum. How many unknowns are there? V1, V2, two equations, two unknown. I think problem solved. See how things are so systematic here. So what are things you are going to take help of? Net force is 0, so momentum is conserved. Then as it is a conservative force, so conservation of mechanical energy. So you can apply these basic fundamental laws and you can get the unknown things. And this interaction potential will decrease. So from where this increase in kinetic energy has come? Due to decrease in potential energy. Gravitational potential. The gravitational potential decrease. The decrease in gravitational potential energy got converted into what? Increase in kinetic energy of the system. So this is a core central idea. Now, sir, what you're saying interaction potential between what? Between point masses. What are M1, M2? M1, M2 are strictly what? Point masses only. No, I always begin with point masses, then I'll extend for bodies. I think that's what we did. No, first we found out gravitational field strength due to point mass. Then what we did? We extended for bodies. Similarly here also, I started with point masses, then I'll extend for the bodies. Okay, able to get this, the overall picture? this thing. Okay, let me give one more example.